This PowerPoint slide presentation is going to be surface loading rate math. Preface as always, I claim no ownership to any of the questions or material presented in this video, as everything I found is sourced off the open internet. In the following slides, I have to the best of my knowledge presented the proper formula and answers to the questions. Making these PowerPoints is a study guide for myself. Putting the information down has helped me learn, cement things in my memory to take my exam. If it helps you too, that's great. As always, I'm the state of Florida. The state of Florida provides you with the formula sheet when you take your exam. This is page 4 of 8. You have hydraulic surface loading rate formula right there. I always suggest if your state provides a formula sheet for taking the exam that you get yourself familiar with it, so that when you're taking your tests, you have a general idea of where your formulas are, so you're not scrambling around to find them. Question number 1. What is the surface loading rate for a sedimentation basin that is 249.5 foot by 58 foot if it's treating a flow rate of 33 cubic feet per second? So, as always, I like to pull out my known and my unknowns for my word problems. What you know is the basin dimensions, 249.5 by 58, and the flow rate of 33 cubic feet per second. What is unknown is the loading rate. The formula for surface loading, or hydraulic surface loading rate, is the total flow applied, gallons per day, divided by the surface area, square feet. Well, first we're going to have to convert our cubic feet per second into the gallons per day. So I'm going to do the 33 cubic feet per second times 60 seconds in a minute times 60 minutes in an hour times 24 hours in a day, and there are 7.48 gallons per cubic foot. That is going to leave you with an answer of 21,326,976 gallons per day. Go ahead and plug your gallons per day into your formula. Now we need to find surface area in square feet. Well, the surface area for a rectangle is length times width. You have 249.5 feet times 58 feet. Leaves you with 14,471 square feet. Plug that into your formula. Do some division. You get a hydraulic or surface loading rate of 1,474 gallons per day per square foot. Question number 2. What is the surface loading rate for a sedimentation basin that is 385 feet by 74 feet if it is treating a flow rate of 19 cubic feet per second? Again, we're going to pull our known and unknowns. Of course, we're doing the hydraulic or surface loading rate for all these, so that's the same equation. What you know is the dimensions of your basin and your flow of 19 cubic feet per second. Again, your flow is in gallons per day, so we need to convert cubic feet per second to gallons per day. This time I went ahead and did the math of 86,400 seconds per day. So 19 cubic feet per second times 86,400 seconds in a day. Now we need to get cubic feet to gallons. There are 7.48 gallons in a cubic foot. So you multiply. You get a total flow of 12,279,168 gallons per day. Go ahead and plug that into your formula. Surface area for a rectangle, length times width, 385 feet times 74 feet, 28,490 square feet. Plug that into your formula, do your division. A surface loading rate of 431 gallons per day per square foot. Question number 3. What is the surface loading rate for a sedimentation basin that is 350 feet by 65 feet if it is treating a flow rate of 14 cubic feet per second? So pulled our known and unknowns out. You have your basin dimensions and your flow of 14 cubic feet per second. Surface loading rate formula, total flow applied divided by surface area. Again, it's gallons per day, so convert your 14 cubic feet per second times 86,400 seconds per day times 7.48 gallons per cubic feet. You get an answer of 9,047,808 gallons per day. Plug that into your formula. Solve for your surface area of a square, length times width. 350 feet times 65 feet, 22,750 square feet. Plug that into your formula. Do your division. You get an answer of 398 gallons per day per square foot. Question number 4. What is the surface loading rate for a sedimentation basin that is 265 feet by 61 feet if it is treating an instantaneous flow rate of 13.4 cubic feet per second? Again, I like to pull my known and unknowns out of my word formulas. So your basin is 265 by 61. Your flow rate is 13.4 cubic feet per second. And we are looking for the surface loading rate. Your total flow applied is in gallons per day. So we must convert the 13.4 cubic feet per second to gallons per day. To do that, we multiply by 86,400 seconds per day. And then to get gallons from cubic feet, there's 7.48 gallons per cubic foot. Do your multiplication, and you get 8,660,045 gallons per day. Plug that into your formula. Now we're going to solve for the surface area, rectangle, that is length times width. It's 265 feet times 61 feet. Surface area of 16,165 square feet. Plug that into your formula, do your division. You get 536 gallons per day per square foot. Question number 5. What is the surface overflow rate of a sedimentation basin if the basin measures 10 feet by 12 feet and is 8 feet deep and the flow rate into it is 700 gallons per minute? So our knowns is our basin dimensions, which is 10 by 12. The depth does not matter in this formula because it's square feet, not cubic feet. We have the flow of 700 gallons per minute, and again, we're looking for the surface loading rate. So you're looking for the surface, not the volume of the tank, just the surface area. Also, flow applied is in gallons per day. This time we're given 700 gallons per minute. So we're going to multiply by 1,440 minutes in a day. That leaves you with an answer of 1,008,000 gallons per day. Plug that into your formula. You need to find the area, surface area, which is length times width. 10 feet by 12 feet. This gives you 120 feet squared. Plug that into your formula. Do your division. You get an answer of 8,400 gallons per day per square foot. Question number 6. Calculate the surface loading rate of a clarifier using the given data. Alright, for me this has already been kind of broken into your known and unknowns. So we're looking for the hydraulic or surface loading rate. As always, in gallons per day. It's total flow applied divided by surface area in square feet. This time they gave us a clarifier, which is circular, and the diameter, and to find the area of a circle given diameter, it's 0.785 times diameter squared. So do 0.785 times 106 feet times 106 feet, which is going to give you a surface area of 8,820 square feet. Plug that in your formula. We need to convert 1.73 million gallons a day to gallons per day. So you times it by a million over 1m, so the million cancels out and you're left with gallons per day. You get 1,730,000 gallons per day. Put that in your formula, do your division. You're left with an answer of 196 gallons per day per square foot. Question number 7. A rapid sand filter has a length of 65 feet, a width of 18.5 feet, and 6 foot of sand media. The flow rate into the filter is 694.44 gallons per minute. Calculate the surface loading rate per day. So pull our knowns and our unknowns. You have your basin, which is 65 feet by 18.5 feet. Again, the depth does not matter because this is surface loading in square feet. It's not volume of cubic feet. Your flow is 694.44 gallons per minute, and we're looking for the surface loading rate. We have our formula. Going to convert the 694.44 gallons per minute into gallons per day by multiplying 1,440 minutes in a day for your 694.44 gallons per minute. That leaves you with 999,993 gallons per day. Put that in your formula. Again, the surface area of a rectangle or square, length times width. Plug in your 65 feet times 18.5 feet. Leaves you with 1,203 square feet. Plug that into your formula. Do your division. Your answer is 832 gallons per day per square foot. So that was a quick 7 questions on surface loading rate math. Pretty straightforward formula. Like a lot of these, you have to take your knowns and your unknowns and get your units of measurement to all match. Again, I like doing these PowerPoint slide presentations to help me learn, and it's helping me remember this information for when I take my exams. It's helping me study. If it helps you too, that's great. Thanks.